Now, we made another little unit here that we specially contrived. This time we have the two magnets together, and we're going to push down on them. How much force does it take to push the two together? The first thing we're going to do is take the 50-pounder. We're going to put a 50-pound weight on that, and we will see what happens. Does it bring them completely together? No. If you look, there's still a space here. They're still not totally together. Marilyn, you put your 25-pounder on. We still do have some space between them, but when we put the last 25 pounds on, 100 pounds, now it all comes together. So you have 100 pounds of force to pull them apart, 100 pounds of force to push them together. These are very, very, very powerful magnets. Now, the next thing I'd like to show you is, how does a motor run? How do you get a motor to go around? Well, you have magnets that are attracted and not attracted, so they push and they pull. Well, normally you take electricity, you would electrify a magnet by running electricity, and you would magnetize the material. The material then would pull toward another magnet or another piece of metal, and then you demagnetize it so that it'll go past it, so you can continue to magnetize, demagnetize, and keep a wheel moving. But you cannot do that with permanent magnets because you can't unmagnetize them. So the reason why they use electricity for electromagnetic motors is so they can magnetize, demagnetize in the proper fashion to get it to run and turn a shaft. Now we're going to show you that you can do that with permanent magnets if you know how to finesse them. David? These are permanent magnets, and there's a permanent magnet at the bottom so that we can use attraction and repulsion in a proper fashion. We're going to turn this wheel for you now, this shaft, using regular permanent magnets. There's not plugged into anything. There's no electricity in this whatsoever, but the wheel is turning. Thank you, David. So those are some of the illustrations of the power in magnets and the way that they can be finessed and used. We can't get into anything proprietarily about exactly the way we're using them in the Hummingbird and the Sundance motor, but I'll show you that, some more footage of that. You'll be able to see them operate. Most electric motors create rotation by using electricity to briefly magnetize and then demagnetize metals and control the push and pull of magnetic forces. By timing when the metals are magnetic and when they are not, they can make the shaft on a wheel rotate. It's that rotating shaft that drives a generator. Normally this cannot be done with permanent magnets, even though it would require no electricity. That's because the permanent magnets, like the name suggests, remain magnetic all the time. Unlike electromagnets, they cannot be turned on and off. We are developing a way to use a small amount of electricity from a battery to unlock the unlimited power that exists in permanent magnets. When that happens, we not only can get the shaft of the generator turning, but we also can feed electricity back to the batteries and keep them charged. We built a 10 horsepower model of the process and tested it before 45 live audiences nationwide. During those tests, we measured the input from the batteries. We also used a professional metering device to measure the work that we were getting out of the motor. The input from the batteries was measured at 450 watts, while the output of the motor was tested at 3.1 horsepower, which is the equivalent of 2,300 watts. We were therefore able to prove that the output of the Hummingbird motor exceeded the input of the motor by a ratio of 5 to 1. In other words, the Hummingbird put out 5 times as much power as it received from the batteries. The extra energy was supplied by the permanent magnets. It is our belief that the project will soon be completed. When it is, we will be able to put the Hummingbird and the Sundance together and begin manufacturing and distribution. This is a model of what they will look like, completed and ready for installation in your home. They're about the size of a window air conditioner and can be installed anywhere inside or outside your home.
The International Tesla Electric Company, or ITEC, is so convinced of the viability of their permanent magnet motor that in late 1999, they sponsored a nationwide tour of 45 meetings in 30 states. This ad, placed in USA Today, was an open invitation to all scientists to come to a live test and demonstration of the technology. The scientists were also invited to bring their own test meters and measure the devices themselves. At 45 shows, the figures Mr. Lee gave were verified, witnessed by thousands of technical and non-technical people. At every stop, citizens were amazed by the incredible demonstrations they saw.